All right, so welcome back. Today in this video, we are going to be going over what is important as you're studying for your Civil FE exam in the mathematics section within the handbook. So we're going to go ahead and dive right in. First, we want to know what part of mathematics we're going to be specifically looking at. So just going to, again, head to our bookmarks within our reference handbook. We're going to come down to the appendix, the FE exam specifications, and we are civil. So we're going to click civil and it brings us to this section. If you're not able to do it that simple, yes, and easy, then just scroll down to the bottom. You should see specifications. It's literally at the bottom of the handbook, and you just want to see civil here at the top. So civil specs. Okay. So today in this video, we're just looking at single variable calculus. So what are some of the things that I would pay close attention to? Well, as you're doing single variable calculus, a lot of it is going to be determining area underneath curves, and then what is involved with calculus, right? So calculus involves integrals and derivatives. So we know we need to be able to do integrals and derivatives. So I want to go to some sections that I think would help you out. So if you want to use your bookmarks again, you can click over to mathematics, and then we can search. A good search term here is going to be, we'll just say, we'll do a control find, and we'll do, because I'm not going through this 502 page document just scrolling. I'm going to use my search term. So integral. All right. So when I type in integral, one of the first things that comes up is integral calculus. But that's not really what I want to see. So mainly what I want to see is the indefinite integrals. It's kind of like the definitions that we're looking for. So here, this is showing the integral of f of x is equal to f of x. The integral of dx is equal to x. So this is just to help you kind of, or to remind you of how to take the integral. So if I know that I'm trying to get the integral of a to the x power dx, and I know that that integral would be, let me zoom in here. If I'm looking at number 9, if I know that it's a number to the x power, right, or to the x, dx, then I know that that's going to equal a to the x, ln of a. So the natural log of a. So if I'm trying to get the integral of sine of x dx, then I know that's going to give me negative cosine x. All right, so you have these as your advantage, or you can use these to your advantage. When there's a, think of that as kind of like sometimes that can be a number. And you just want to keep that number as it transfers over to the integral. If you haven't done integrals in a while, it may be a good thing to do some kind of searches and making sure that you know how to take the integral or basic integrals. We'll look at some examples, but I wanted to make sure that you knew about this section that can help remind you about, you might say, okay, how do I take or get the integral of cosine? Well, it tells you here. How do I get the integral of sine? It tells you here. So they're definitely going to have probably one or two problems on that. So between integrals or derivatives. So another section that you need to know is derivatives, right? So how do I get the derivative of a number or of a constant? And if I say the derivative of 5, it's going to equal 0. It doesn't matter if I say the derivative of 100. It still equals 0, right? The derivative of, we'll do another one. The derivative of natural log, it equals 1 over u. And then the derivative of u. So sometimes these can get pretty crazy with whatever u is in. So u may have a variable within it. So like I said, if you need a refresher on these, I do some examples, but if you need more refresher, then you can look up some stuff as well to kind of familiarize yourself with derivatives, right? What's the derivative of tangent? Well, it's secant squared, right? Du dx. So just playing around with these and knowing that these are here for you is going to be pretty important. Now they don't get too crazy with these. Like they may throw, you know, a tangent or sine, cosine, and put some extra variables within the u. But they don't get super crazy with this. So you just need to have a basic understanding of it. But you don't have to, I say all that to say you don't have to remember all of this stuff, right? It's here for you. Just make sure you've done enough practice to kind of know how to do the problem, but you don't have to try to remember, okay, the derivative of sine is cosine. It's helpful as far as time is concerned, but you don't need to have all that in your head. Just know that you have the handbook, to help guide you along. So that is all. That is going to be all for this section. Integrals and derivatives, area underneath a curve, and being able to solve those are going to be pretty key. And you'll see from some of the examples I go through, you'll be able to knock those out. But that is all for this video. I will see you in the next one.